From the Nansen Research Institute. We are arranging this session today. So if you think about transformations, particularly in cities and the Arctic region, what is very essential for transformation is the engagement of people and making people aware of the transformations and being a part of that. We are particularly interested in that in the Arctic region because the Arctic region has many rural and dispersed communities, and it's often very difficult to engage the people, to reach out to the people, to make them a part of it, particularly to get their input. And we are exploring the use of digital technologies and how digital technologies could, for example, alleviate some of the challenges that people face in these regions. So that's why the focus of this workshop is digital transformations and the role of, city transformations and the role of digital technologies here. It is related to a lot of the research projects that we are working on. In particular, we are working on a project that's called Ursa Mayur, which in short is urban sustainability through joint organized research schools. And one of the tasks that we are working on is actually the use of digital technologies to visualize some of the climate-related information, because it's often very difficult for most people to relate to that kind of data, and we're not environmental scientists, most of us. So the role of technologies is quite interesting for us. And welcome once again. Thank you very much for your interest, and I am so happy to see a lot of people here. At this point, I'm going to hand over to the session chair, Professor Alanka.
Hi, welcome everyone, and I'm really happy to see you here. We have many good discussions today, many good presentations today, and in the first round, in the morning, we have around 8 presentations. In the afternoon, we are going to have some more presentations, around 5. And after each presentation, I will just ask presenters to present their, in 10 minutes, to present their work, their thoughts, their ideas, and discussion will be organized at the end. We have representatives from the Arctic University, from SINTEF, from Nansen, from NTNU, and also from Luleå University of Technology. The topics are very exciting. We are using this moment to discuss and also to empower, to show how we are empowering citizens by using technologies. So some keywords which are going to be discussed today are about the data flows, about digital twin solutions, about microclimate simulations, about air quality and assessing measuring factors, about X-ray technology, how to use those in a built environment, about the role of digital technologies, about utilizing the technologies from different user perspective, and health and safety issues. So very, very interesting. The first one is Professor Igor Ezau. Please.
Don't we have pointer? No? Yes. Yeah, thank you for giving me time slot in this presentation. Well, I was behind this Ursa Major project, initiating it, and I'm really excited about this combination of digital solutions and solutions, communication solutions to present it for stakeholders. We are living actually in a very interesting time when computer development, software development is bringing to us so interesting solutions and so powerful solutions that we can see in virtual world, imitate in virtual world everything what is around us. And this is not only at global scale, as say European Destiny program aimed to create a digital twin of the whole Earth. So it's not only global scale which we aim to, but also we can work at we also look at local scale, where we can represent everything what is going on around us with high resolution, in this sense, turbulence resolving, meteorological component of smart city digital twin. What we are talking about, what are smart cities and who does care? Smart cities, it's another way of thinking about organization of urban life. Instead of combination of water supply, sewage, whatever, governance, transport, and so on, it can be all organized around citizen. Citizen in a center, and citizens contribute to different aspects of urban life. Here, because I'm a natural scientist, I'm computer scientist in a way, I'm touching only modeling of environmental component of urban climate, urban air quality, and urban environment. And we can simulate this urban environment in a way to make citizens in center of improvement of environmental quality on very fine resolution, very fine scales. Unfortunately, this part of thinking, this part of digital solutions for smart cities is still underdeveloped. We know very good solutions for economy, ICT, for transport, innovations, employment, and so on. We use it when we use buses, for example, but we don't know good solutions which organize green space in a city, white space, open space in a city. And in many cases, for example, managerial solutions to improve air quality incompatible with objective laws of diffusion, pollution diffusions in cities at high resolution scale. So we can get places where people suffer with worse air quality than necessary, or they get less access to green spaces, to clean air and nature. We need integrated urban service system, so-called UES, and this need has been advocated by special programs by the World Meteorological Organization. But when we try to construct this integrated urban system, we have a problem that our model, meteorological model, weather prediction model, they are not working at urban scales. The finest resolution of the Norwegian weather prediction model is 1 kilometer. So one kilometer in such complex terrain as, for example, here or Tromsø, the whole island is 4 kilometers across. So it will be 4 grid points, and we will not see much about what is going on there. So we need another model. And such another model indeed exists. Such models have been in development for 20 or even more years so far. The key problem of transition between meteorological and so-called turbulence resolving model is that you need to resolve turbulent motions, three-dimensional motions in the atmosphere, which create diffusion of pollution and create local flows, transport pollution from one place to another place. I pay so much attention to air pollution, but in fact, they are also important for many other factors, also for microclimate and urban comfort. Someone may think that urban heat island, higher temperatures in urban areas, is not something important in boreal environment in Arctic cities, but in reality proved to be absolutely opposite, because in high Arctic we have permafrost permanently or very long frozen ground, and if we have higher temperature, that will reduce stability of the ground and create a lot of damage. Some studies attribute to this ground weakening 80% of damage in the Arctic cities. That cost, by estimation of our American colleagues from George Washington University, that cost about $2.5 billion every year to Arctic cities. So what we are using here? There are many relatively advanced codes which can work with high resolution atmospheric environment. We use this one, the parallelized atmospheric Lachedi simulation model, PALM 4U, which means for urban simulations. This model is built up on quite advanced numerical solutions, implementing also nesting, so it's possible not only to simulate the whole urban environment over a municipality, I will give an example just now, but also zoom in particular places consistently, I mean physically consistently, numerically consistently, zoom in specific places like particular square with high air pollution, for example, or to some building which introduce particularly bad conditions. That model is now used by many groups around Europe. Also, for example, here you can see an example from Helsinki by our colleagues from Helsinki University. A lot of usage of this model in Germany, in Japan and China as well. So quite significant community trying to develop the model as an instrument. But what is missing? They are very good in doing modeling, but how to relate the modeling results with stakeholders, with those people who made the decisions? Because communication here is not that easy. We are very used to look at such kind of maps, for example. We understand that this is Bergen, this is a central part of Bergen, Walken, where cruise ship usually park, and cruise ship induce huge amount of emission. So you can see the situation, how this emission from cruise ship affects the central part, the most attractive part of Bergen, the capital fjords in Norway. We used for this, yes, I'm almost done. We used to this maps, but not stakeholders. They want to resolve this problem, visual problem. So we need to communicate numerical maps, numerical results in visual way, or at least, I will skip it, the last slide here, or at least give very clear instructions what they about to do. And this plot actually presents how they can clean air just implementing certain measures, substitute old exhaust to new exhaust turbines, and make it clean for practically everyone without drastic loss, I would say. So that is possible now, and since I don't have time, thank you very much.
Thank you, Igor. The questions are coming later. Please, Johannes. And also the other presenters, please, can you speak in microphone because we have persons online.
Yes,
Thank you.
sure. Let me just move to the side here a little bit. That's all right. Yeah, thank you for giving me the opportunity to present our work in this forum, and also thank you, Professor Igor Esau, for this perfect introduction for my talk. This was really great. And yeah, so I will show you today how my colleague Are Simonsen and I from SINTEF use computational fluid dynamics to simulate and visualize airflows and microclimatic conditions in high-latitude urban areas. I'm writing high-latitude because technically not all the cities, or the case is Trondheim in Norway, so not an Arctic city per se, but still high-latitude, and I think the principles are still applicable for Arctic cities as well. I'll skip that. Just to show you some relevant scales on the top here, you can see the meteorological scales, and when I talk of the microclimate, then we're sitting at the lower end of these meteorological scales. The urban climate touches also upon the lower end of the meteorological mesoscale, but the urban microclimate is in horizontal extents of between like 2 meters to 2 kilometers approximately. But why do we have to give the urban microclimate specific word? Why do we have to use the specific term for that? Why is it so special? Well, that's because the system is extremely complex, and it's made up from different spheres, and usually the biosphere is quite reduced in an urban setting, and also with the urban hydrosphere, the canalization, the sewage system, water from precipitation events is usually taken away very fast, which has a distinct impact on the surface energy balance of cities. And of course, we have the built environment with roads, with buildings, heavy materials, obstacles to wind and solar radiation, which has, of course, a distinct influence on the wind conditions, on the solar conditions, and also how people move and behave outdoors. And what challenges are coming in addition to that in high latitudes? Well, as all of us know, probably most of high latitudes are considered to be cold or Arctic and polar climate. That means it's usually heating dominated, but even though two locations might be considered or classified by the same climate type, the variability of solar radiation can still be very, very huge, which we can see in the case of Tromsø particularly. This means that when you move around the city center in high-latitude cities, especially during the winter time, it's very unusual that you will get a lot of direct sunlight because of the low solar angles. And the heating-dominated climate, I already mentioned it. We usually have a lot of snow and ice, as you've probably experienced outside, and you can also see the snow falling down now at this moment. And as Professor Esau has already told us, and may be quite counterintuitive, but we have an increasing risk from heat waves also in the Arctic. Especially vulnerable population groups are especially at risk from heat waves because the populations in these areas are simply not used to extended periods of heat. And also the Norwegian Meteorological Institute has shown that, in fact, heat waves have occurred much, much more often during the past decades, reaching a maximum in 2018, where we can see also in the very, very north of Norway that heat waves occur indeed more and more often. But now, how can we investigate the urban microclimate? Traditionally, this was done by measuring. This has been done for centuries already. You can mount sensors on any kind of vehicle. You can use satellites as well. You can use wind tunnels like here, or you can use weather stations and infrared thermography, as we did in the case of Trondheim. And the other way to study the urban microclimate based on the use of measurement data is to use numerical modeling, and in our case, computational fluid dynamics. of course, with the advancement of computational power, these have become increasingly better applicable for this purpose. And yeah, CFD is basically to use computers to analyze problems that involve the flow of fluids, and in our case, air. These are able to cover more and more physics and increasingly large areas, which makes it perfect for our application. And now some examples from the university campus in Trondheim that were done during the past years. You can see here it's a quite large area of 17 square kilometers with the university campus in the very center. And we studied the impact of materials and vegetation on microclimate with regard to the building energy demand with this particular study. When we zoom into the center area of this model, we can see that the geometrical detail is fairly high, and even the trees from the surrounding park are modeled with a quite good detail. And not only the shading from the tree crowns was considered, but also that when the air flows through the tree crowns, we add turbulence to the airflow, and we slow down the wind speed. Plus, we have evapotranspirational cooling from the tree crowns during summer. And the purpose or the methodology of this study was to simulate different microclimatic scenarios. I will not go into too much detail because I'm really short on time. For different one-week periods in summer, autumn, and winter, exported these climate files around an example building in the center area of this campus into building performance simulation program, and compared the building energy use for these different periods with each other on the basis of the different climate files from the different microclimatic scenarios. And without going into too many details again, removing all the vegetation, when you remember the park around the university campus, if the campus would not have been surrounded by a park but by a concrete desert, that the example building would have used in summer 26.6% more cooling energy during this one-week heat wave, which is based on real measurement data. So it's not completely fictional, but it's real measured data that went into these models. Another application is this incident that happened at the university campus, where during an experiment poisonous gas leaked out and injured 3 employees of SINTEF. And this poisonous gas was then extracted by the ventilation system and was let out into the air and surrounding on the university campus, where there are a lot of people. And what we did, we used the same model and checked how this pollution, this cloud of toxic gas, spread out in this area. And as you can see, this mostly was take place in the roof area, as it slowly dissolved into concentrations that were no longer dangerous to human life. So coming towards the end, CFD is a really powerful tool with a large range of possibilities and applications. There's generally a lack of studies in high latitude and Arctic locations using CFD, but we really need solutions to improve the resilience of cities, to improve the livability of city dwellers, and improve their health, especially in the face of climate change. And other areas of application of CFD modeling techniques could be, for example, also natural ventilation potential by combining indoor and outdoor studies, the urban wind energy potential, which is not focused on at all, sadly, wind-driven rain and snow accumulation, or from a pure fluid dynamics point of view, the airflow and statistics above urban areas is also possible. And that was my last slide. Thank you for your attention.
Thank you, Johannes. Now Lasse is the next presenter.
Okay, thank you, Alenka. nice two introductions here on the subject, on the modeling, and I will go in a little more deeper into what we've done in the non-Arctic city of Bergen, southern Norway. This is a beautiful picture of a winter situation in Bergen, where oops, that was next, so back, and typically here we have the harbor area, the fjord. There are even some ice here very frequently in the fjord, but the atmosphere is really what needs the attention here and what takes the attention of the citizens of Bergen, and that is the haze or fog or the poison lid. A lot of names used on it, but it is the inversion due to the meteorological inversion and the accumulation of the pollution close to the Earth's surface of the city under some weather conditions. So this is a work that I've done together with Igor and Tobias Wolf, who used to be a PhD and a researcher at the Nansen Center. Now he's working in Oslo municipality and in the planning section there, working with air pollution. So I go a little into the air pollution in Bergen. Here we capture a few weeks of news stories about the pollution in January or in 2015, 2016, and there is a lot of attention. And the attention is on the sources of the pollution. The sources I will come back to, but the local engagement has been there, and in Bergen is there. So we have the citizens' support and to looking into this issue. So the challenge from a scientific point is to bring the scientific facts into the story and so on. Now address that. So the three main sources in Bergen is the cars, it is the households that are burning woods to keep heat hot, and it's the ports that come into the ships that comes into the port and leaving the engines on for the electrical supply. So from the local administration, we have the density here in green of the buildings and purple, high density. So we know something about the emissions from the households. We have the main roads, we have the side roads, so we know something about the traffic and can assess the emissions from that. And we also have quite detailed records of which ships are in the port of Bergen, for how long, and what type of emissions coming from the different classes of ships. The public authorities in Bergen are doing monitoring of pollution, like following national regulations. There are 5 stations around in Bergen located on, oops, that was located around the city, in the city center, in the suburbs around, and out where I'm living. So they have 5 measurement stations, and of course it's highly undersampled. What kind of information can you tell about the whole municipality? What are the air quality in the whole area here, based on some of the stations that are located in the central parts? So as both Igor and Johannes pointed out, modeling is a tool where we can go into high resolution and look at the distribution of the pollutants. Just briefly telling here, this is the analysis of the data from the observations, and you can probably not see it, but this is the month. So it's typically a problem where you have high pollution events during the January, February, March, and from October onwards. If you look at the time of the day, it is an issue that yes, this is for particles. So it's could be some particles during nighttime, but also during daytime there is an increase from the morning when you start lighting up your wood fires, and towards the later time of the day. And then also for the last one here, it's the car traffic, and you see also that there is more activities during the weekdays and less activities during the weekends. Okay, so that was the data. So what have we done? We have at the Nansen Center, we installed first with the project that Igor was having at the Nansen Center, MTP, a microwave temperature profiler. That is measuring the temperature profile from the surface up to about 1,000 meters. Here you have a typical profile over the city of Bergen. We could have situations where you have inversions, where the curves goes like this, and then that the pollution is blocked in the lower layers. We're combining that with the pole model that Igor has explained, and then we make simulations of the impact of both the topography and of the buildings in this city center on the spread of the near surface pollution. Igor showed this, got a lot of attention. We knew it was coming, and we turned around, and he also showed this one, that we did a simulation, a plot that is easily, as he said, understandable for scientists and maybe for some manager, but okay, it is not the picture that you see here. What really takes the attention is what you see up here, and of course that's too high to have a direct impact on people walking down here. But this really demonstrates with the simulations that the pollution from the vessels here is pushed down to the 1 meter level above the earth and in the area where we are walking. So we tried with a traditional chronicle to convince or to tell the story here to the citizens in Bergen. Things has happened with the ships in port. Bergen port is now electrified. So they're offering electric supply to all vessels coming into port, and there are also very strong energy certificates and fees issued with the different kind of ships that's coming into the port. Then we can look in the winter situation, the general situation. We know the roads and the emissions along the roads, and we see that the main road through the city center, here is the highest pollution going into the city center and to the parking lot here in the city center. So we can follow that, we can simulate it, and we can look at the impact from the various sources on the total air quality here for NO2. And we see also that the two major sources from our simulations here are the ships in the port, mainly influencing the local area around the port, and the cars. We can do similar simulations for the fine particles. Then it is the wood firing in each of our homes. That's the main source. And we see also that the distribution is located in the area where the highest density of households or individual households with wood-burning fireplaces. And then in some areas we see that also the car traffic have a big impact located to the main roads, and also the impact of the ships in port on the particulate matter. So these are the type of scientific output that we want to share and use in public administration in making decision makings. So we looked at all the wood firing places in Bergen and did an assessment of what will happen. This is today's situation where we have around 37,000 clean burning fireplaces out of total 80,000. So if we make all these fireplaces in the city clean burning technology, new technology, then that will happen. Major problem with the pollution will disappear, and of major parts of the city. But we also see that in some parts of the outer parts of the city, the impact will be some, but not really targeting the main area of the high pollution. So, yeah. Information being shared with the municipality, and proposing then that they should go more into targeted, looking at the different districts of the city and how they can look at one district, where does that have an impact, and if you put your measures into certain areas or districts of the city, then you will have higher benefit than you have in general measures all over the municipality. Igor showed this. It is a complex figure. It's on the emissions from clean burning technology compared to non-clean burning technology. But the key message here is that citizens or households moderately impacted by air pollution from wood firing is around 18,000 in the first scenario. And if you have only clean burning scenarios, only about 1,000 households are impacted. And the same for the high impact, going from 4,000 down to around 0 households. So in summary here, what can we do with high-resolution simulations to support? I have been addressing these issues here related to air pollution, but there are also other applications, as Johannes also mentioned it. We can go into extreme wind, we can look at temperature, freezing, precipitation. How should you plan your resources on removing the snow, etc., and sanding or putting salt on the main roads in the city. Yeah, and what I'll just say here, what it says here is a Norwegian newspaper. Ban on old ovens will give 9 out of 10 better air quality. And that was a few years ago, 2018-19. And now the municipality is closing the bans on, now you can. They have come to a point where so many ovens has been replaced in Bergen that there is no need to have a full ban on using old ovens in the city. And Ursa Major, I know the time is out, but okay, this is the way the politicians and the planners want to visualize the future of cities, developing new buildings and constructions here. And our task in Ursa Major is to put the pollution into between the buildings here, and how will this new infrastructure have an impact on the local development of a city like Bergen. So thank you for your attention.
Thank you, Lasse. And now we are asking colleagues from SINTEF to join us, Björn Rude and Per Sturre.
Right. Thank you for having us. So this is an abstract for a paper in progress. Our names are Bjørn Jacobsen and
Per Sturre Petersen.
Yeah, and the title is using immersive technologies for citizen engagement towards sustainable urban development.
Yes. So the definition for citizen engagement, which we are working with, is the following. Citizen engagement refers to a particular type of involvement characterized by interactive and iterative processes of deliberation among citizens and between citizens and government officials. So that is taken from Phillips and Orsini. Yes. So the hypothesis that we are working with is that immersive experiences enabled by XR technology, which Björn will come back to the definition of later, it can be leveraged towards citizen awareness, collaboration and action in relation to sustainable urban development. In order to have our hypothesis confirmed or refuted, we have had activities such as a workshop designed around using XR technology for visualization and interaction in relation to citizen engagement, and that was also in order to assess the user's perception towards using XR for this purpose, and also to try to receive proposed uses for XR from the participants of the workshop.
Okay, but what is XR? This is a term used alongside immersive technologies. It's an umbrella term for different type of immersive technologies, whereas the two most common forms of it are augmented reality on your left and virtual reality on your right. These are both headsets you wear on your head, and you're given three-dimensional virtual objects or elements or environments. The difference being that AR superimposes virtual objects on your physical reality, whereas in virtual reality, your physical reality is completely substituted for a virtual one. And you're able to interact with these virtual objects as if it was real ones, without the physical sensation, of course, but you can grab them, scale them, manipulate them, and do different things with these objects and environments.
The often emphasized qualities of XR in the literature is immersion, presence, which is the subjective feeling of being in the simulated environment, which inherently leads to engagement, which is the term sort of used about the feeling of novelty and the feeling of experiencing the sort of data or scenarios that you are given in the simulation.
Basically, XR is usually a very fun experience for people to participate in. So, visualization is a key term in XR, it can overcome a lot of the traditional limitations for visualization tools. For instance, you can communicate tangible features such as the size and the scale of a model, or true size and true scales. And you can actually experience the data firsthand in a way you can't do on a flat screen, for instance. You can also make invisible processes visible, such as in the case of air pollution and air quality in Bergen, as mentioned by Lasse and Igor. And it can also reduce the cognitive requirement to understand the challenges or proposed solutions, and thus increase understanding. So, using XR enables users to interact with the environment in a very natural manner, and this substantiates established learning paradigms such as constructivism and experiential learning.
Yes, so as mentioned, it is a good tool for contextualization. What we see here on this slide is two examples of VR softwares. The one on the left side is from an application called Greenland Melting, where you can actually experience the effect of climate change on the ice in Greenland. And the application to the right, which is called Sea Level Rise Explorer, I think it's on the west coast of in the USA, where you can see how an increased sea level affects the environment, the natural environment of a small community at the seashore.
Yeah. So this is a picture from Ursa Major International Workshop where we conducted at SINTEF with Alenka and Soba. We provided the students with VR hardware and provided them with environmentally themed content, and then asked them to fill out a questionnaire. So we're still analyzing the data, but the data indicates that XR is purposeful for citizen engagement activities in relation to urban sustainable environments. Sustainable development, sorry.
Yeah, so to summarize, as Björn put it, that our data indicates that the use of XR technologies can potentially lead to increased citizen engagement. So we can perhaps just mention that we are using measurement tools such as the user engagement scale and also some of the constructs from the technology acceptance model, and also some custom designed constructs. Yes, and we should also mention that we are collaborating with Dr. Shubham Jain from NTNU on this article, which is, as mentioned, in progress.
Thank you.
Thank you.
Yeah.
Thank you both also for keeping the time. Sobach is next presenter.
Hello again. I'm going to talk to you about the role of digital technologies in engagement and participation, digital divide or inclusion. This is work done by, in the broad context of the research that I am involved in, which is about how cities evolve, how cities develop, how cities learn and transform by understanding themselves better or by learning from another city itself. It's partly related to the work of one of my PhD students, Pradipto Banerjee. But it also relates very much to the work that we're also doing in the USMIO project. You might be familiar with the approach of living labs or urban living labs. This is quite popular at the moment in terms of understanding cities and supporting transformations in cities. Basically, the idea is the entities in the cities should connect. You should engage with the citizens. You should get input from them by actually engaging them in designing new services and transformations within the cities. They should not be lab experiments, rather they should be live experiments out in the real world within the context that you want the transformation to happen. And you should have a feedback loop, like in learning theories as well. In this particular context, we should also have a way that we are actually responding to the citizens and delivering to them what they want and engage them in the transformation process. So it's not surprising that we connect this also to our approach in understanding and learning in cities. So very often when we talk about these kinds of transformations where we engage with the citizens and have co-creation activities, we come into the concept of understanding what is a place and what is a space. Because often the co word indicates that you're kind of time and space bound. You have to be co-located at the same place like we are now, and we have to be doing something together physically in the same place. But this is not always possible for a number of reasons. On the top right there, you would see how we were working when we had the COVID-19 restrictions. But more so, this is quite relevant for the Arctic region. And you might be wondering, I actually grew up in the Maldives, which is a tiny group of islands in the Indian Ocean. So when you're geographically scattered, like in an island community or in the Arctic, you have a lot of different dispersed parts of the population that are hard to reach out to. And so we have to come in with the idea of, say, could technology then bring us together? Could that be a way that we can engage more people there? And therefore, on the right-hand side, you see actually how we have used technology to engage people as opposed to sitting together and working with more tangible stuff together as well, which is perfect, but we also have to adapt in the different contexts that we work in. So without going into a theoretical discussion on place and space, I just wanted to highlight the role where the place, the physical place, could be made into a working space or a collaboration space or an engagement space by using different kinds of digital technologies. So just to give you a little idea, what we decided to do was, and I'm going to talk about a little experiment that we did, a field study that we did when there was a street festival in Trondheim where we kind of piggybacked onto that situation. We used a commercially available tool, a digital tool to engage people, and we thought, okay, how does this work? So basically, the tool is designed around the concept of trilemmas. So instead of being given a survey to choose one, you're given a set of 3 options, no right option, but you have to choose what's best in that situation, which means it should stimulate a process of reflection in you, and then you decide to kind of do a trade-off and decide what's best for you in that particular situation. And then the idea is that people could choose one, and then at the end, that pie chart in the figure shows the choices made by the different people. There are no right and wrong. It's just some are better in some situations than the other, and we're hoping that it would stimulate a process of reflection within the people. Right. So we use this technology in a street festival in an area called Algesater in Trondheim, which is just kind of below from the main NTNU campus. And there's a lot of discussion about development in this area at the moment for a number of reasons. It is along one of the main streets that comes into Trondheim, so about 20,000 vehicles drive past it every day. There are people who live there, including families, students. There are a few businesses also there, but it's really developing. And also with NTNU talking about developing the campus area physically, this is going to be one of the areas that is going to be affected a lot. And they just don't want to be infested with a lot of students or any one particular type of people. And so this was an activity to engage the people in that area, which Alenka and her students were really involved in. And we piggybacked on it by providing the tool. The way the tool works is you get this QR code, you can, on your mobile, then get this set of trilemmas, and you have to make choices. So we thought, let's try it out. We have tried this in organizational situations, more time and space-bound workshops, and now we wanted to take it into, okay, can we do it in the city space, engaging people in an area? The main event during this was in the middle of it's a whole day festival, and in the middle of the day there was going to be a panel debate. And as you and I know, in a panel debate, sometimes we're a little bit shy to raise our hands and talk to them. Being time and space bound, you don't always have a chance to include everyone's views, even if they were not shy. So we thought, well, why don't we use this technology to pose some questions related to the topic of the panel debate before the panel debate, and we can then bring it to the panelists, which include people from the Kommune, which included people from the student housing department, the Trondheim, the Trondheim, yes, housing, yeah, and so on. So what we thought was we could actually collect the input from the people and bring it to the panel debate. And that's what you see here. So we had a few questions like, how would you like this area to develop? What do you think who do you think influences development in your neighborhood, and so forth? And posed some of these trilemmas to them to see the opinions of the people. And then you have the panel debate, as you can see. Unfortunately, the facilitator of the panel debate was not aware of it, so this was not actively used. But what we did was we actually went and had interviews with the municipality director, the people who were in the panel from the student housing department and the Trondheim area development people, and then said, well, these are the results that you have seen. And what they were saying was, it made them reflect. It was quite nice when we went and interviewed the municipality director. He actually got up and he said, I have to look at this more carefully. I'm surprised to see this result. Let me reflect on this. So in a way, we didn't have to survey, but their responses actually showed that this was meaningful, right? The data that we had was very small set of data. We only had like 20 people responding to it, which doesn't make a big difference. But at the same time, the fact that this kind of data could provide input for a panel debate or make somebody who is responsible in decision making in the development of an area actually reflect and say, well, this data surprises me, I hadn't expected this kind of thing, kind of tells you something that this could be a way to engage people. It could be a way to include more people into the engagement process, into the discussion, into the public debate about something. And that's kind of what we wanted to do. We also wanted to ask people what they thought of these kinds of technologies. And again, we provided them 3 options. Does it help you convey my ideas? Does it help you share your ideas with your neighbors and so forth? And we actually did get quite positive results from the people. Or I would say that this is positive because they do say that it does help them convey their ideas. Now, going back to the idea of the living lab, in a way, this is sort of what we call asynchronous, not time-bound or space-bound way that you can actually get people's input and engage people into a, let's say, a public debate or a process that requires some kind of decision-making. And not only that, it brings together the different parts of the city. So in this particular case, it's kind of making connections among the citizens, the municipality, the housing department, and so forth. So in our broad research idea, where we're trying to understand the city and the elements within a city and their interactions, this is actually trying to create bridges across those and bringing in this idea of the partnerships, which is one of the UN Sustainable Development Goals as well. So in conclusion, we're kind of at the moment working on identifying the benefits and the challenges that are involved in using digital technologies. Of course, people could contribute anonymously, which is favorable to a number of different people. You can enhance the outreach to dispersed communities and peoples, particularly in the Arctic region. This can be a very important way to engage more of the citizens in making decisions or providing the information for decision making. You have the enhanced time and place for participation. It's not time bound. So I missed the train today and I couldn't come. I'm not excluded. I still have a possibility to contribute to that. Build a relationship to the transformation process. So often we're very disconnected from what's happening. If you are a part of being engaged and thinking about it, then you have it. But of course, with any technology, you have the challenge of onboarding people. The design of the application in terms of user friendliness is a big issue. So that concludes my presentation. And if you want to contact me, that's my email address. Thank you very much.
Thank you, Sobach. Now we have a challenge. I'm not sure if the next presenter, Dr. Clara Good, is in this room.
Yes, there's Brian.
Yes, please. Yeah. Then Brian is going to take the...
Regrettably, Clara's not able to be here today, and she is the leader of our project, which was initiated by Professor Vegard Nergård, and it is in conjunction with UAT, other colleagues around Norway, and colleagues at the University of Cambridge. The idea we have for the Green Phoenix Research Initiative essentially is looking at what happens to the buildings that are constructed in Europe from 1945 to 65, the complex heritage and history they have. For example, the city of Le Havre in France is now World Heritage, whereas other cities, for example in Plymouth, the brutalist concrete architecture is not really that appreciated. And also, how in a green transition do we do ways in which we can retain community and heritage values while at the same time making them applicable to the 21st century. Here in northern Norway, at the end of World War II, the retreating German forces burnt down the majority of buildings in Finnmark, across here to Troms as well. Based on their perverse racial theories, they evacuated the Norwegian population, thinking that they were more racially pure than the invading Russians. And so there was this huge trauma that happened. Built environments with their diversity of Kven and Sami and other types of Norwegian architecture went on to be replaced by quite a monolithic form of architecture. And so in the rebuild of the north, the reconstruction, there was a series of designs. People were able to choose these. Husbanken would then provide finance, and then people would choose the structure, the design, and then they would modify it over the years depending upon their budgets. So when you drive from here across to Kirkenes, you'll see a great uniformity of these buildings. And also these buildings are very much southern buildings. So the diversity that was here before is no longer present. These are the types of buildings you'll see, either in more isolated areas or in Hammerfest. There is now a region which is considered a heritage zone. So how do we get an appreciation of what we have nowadays? So there are obviously the building records, and there we're accessing digital data. We have issues of privacy there and anonymization as well. Then we can use remote sensing. We had a field trip last year, and what we noticed was that what we called the warts of wealth have sprung up all around these buildings. So you'd see the original building, and then there would be new balconies and extensions this way and that. And so what is actually present is quite different from what was built in 45 to 65. Can use technologies. One of the things here which Gareth was quite bemused at was this LiDAR ghost aircraft. But it does give us an appreciation of the types of roof areas that we're looking at. Of course, in the terrain here, there are issues of actually getting the sunlight. Besides the obvious fact of being above the Arctic Circle, there can be large variations. So getting an appreciation of the energy available to be generated is an issue. We're looking at different types of software for how we can engage, and I really do appreciate the comments that colleagues have made to date in this session, and it's ways in which we can engage with a geographically diverse range of people, a culturally diverse range of people, in a range of ways. And one of the things we're particularly interested in is what is an important view for you? So could you place on this map showing this view from the beach looking up to the houses is really important. The view from the hill with the road, maybe not so much. So if we want to put solar panels on one place, where would you put them? Okay, we protect the view from the beach. We've seen examples here in northern Norway of these buildings that have had these panels put on. Clearly there are technical changes, and with environmental change, especially I think with ice heave, there will be structural issues. But they have worked, and they have worked very efficiently. We've done a test scan using a drone, and then here we've rectified it so we can get the measurements. It's also a good opportunity too to see what condition the roof is in. So for example, there's a slate missing there, another slate is sliding down here. So for homeowners, it's a good opportunity to get an appreciation of an area they don't normally access. We did a visualization here, essentially at rooftop, but ultimately we'd like to also do it at ground level. One thing that came out straight away was the people said, we don't want you looking in our windows. But we will be able to get permissions for that, I'm sure, in the future from various people. And as we come around the second time, the visualization has added to it where solar panels could be on the right-hand side. They should be popping up at any moment. There we go. And you look at the shape and you go, well, maybe if on the left-hand side it was more in line with the angle of the roof, would that be more attractive or not that attractive? Thankfully, there are panels now coming on the market which look very similar to existing building materials. Then we can empower people by showing them what's happening with their use of green energy and how that's contributing. There has been an issue of people actually using more energy because they're getting free energy as they see it, or cheaper energy, but it empowers people individually in their homes, but also perhaps there could be groups of buildings which could have storage of energy over the summer for utilisation in the winter, and this gives them a good way of understanding that. So I'd like to conclude with, I think, one of the more profound statements in science and technology and environment. Technology is neither good nor bad, nor is it neutral. So one of the things we're looking at the moment is cultural sensitivity, people that may not want to share in terms of what has happened in the past, people who may want to share and want it anonymised. And also we're looking into XAI and how do you actually explain what's going on in artificial intelligence? Is the algorithm or algorithms actually aligned with cultural heritage values that may be part of a community? And just saying, oh, well, look, we put it into a black box and something comes out of the black box, we've moved beyond that. That's no longer acceptable in a lot of ways. And also there are compromises to be made. And what those compromises will be made with heritage values, which are complex, societal values, technological resources, will be challenging. But it is one of those things that by engaging with the community in good faith, with co-production of knowledge, and bringing a range of people from the humanities, social science, as well as engineers and technicians, I think we'll be able to achieve great things. Thank you so much.
Thank you. And now the last presentation, Eugenia, please.
Thank you so much. And I'm also presenting a paper in progress. My name is Eugenia Segerstedt, and I'm working on this paper together with my colleagues Kevin Lau from architecture and Maria Johansson from human work science, just as me. Just a second. Is this one the click? Thanks. Yes. So, due to massive transformation in the Arctic and subarctic north, and especially Swedish Arctic and subarctic north, and this transformation is connected to demands for sustainable energy production, diverse social issues are arising. And among those, housing demand is one of the important ones. So what we are trying to address in this conceptual paper is to address this issue from three angles: from physical planning, construction work environment, and community perspective. So as livability and social sustainability concerns are important when this green energy transformation is discussed and considered. Those issues, while planning for transforming communities and transforming urbanities, are often addressed through the lens of bigger cities and warmer climate, even though a lot of those communities are placed in Arctic and subarctic climate, and those communities and those urbanities are relatively small and have special urban character. And those issues have been addressed in several scientific projects, among those ATTRACT, financed by Vinnova, Swedish Research and Innovation Agency, and it has been addressed in several multidisciplinary dissertations. My colleagues, Tim Johansson within the fields of construction, Erik Hidman within the field of architecture, and in my dissertation from 2020, which is called Small Town Big Move, from the point of view of community studies. And it's fascinating to be able to present this conceptual paper in this room, because this dissertation contains a paper on co-creative place innovations, on 3D mapping of social sustainability issues, And I see several overlapping ideas in this room. I've been using living labs as a method as well. So happy to be here today. And when it comes to research gaps and to risks identified when there's transformation connected to the new industrial wave in the subarctic and Arctic North is discussed in research, I would say that that those issues are to some extent addressed from the point of social sustainability, as we point out in the paper from 2019, together with my colleague Lena Abrahamsson. But however, this research and this analytical review that we made was based on the following transformations connected to the industrial processes of 2010s, I would say, 2016 the latest. And now the new wave and new context is coming. So how are those issues of providing sustainable housing can be addressed when fly-in, fly-out challenge reactivates in a way, when access to workforce it becomes a bigger challenge than before. So, as we suggest, it should be addressed from 3 different angles, which don't seem to be combined in this way in earlier research. It's from the point of view of physical planning, construction work environment, and community perspective. And what do I mean by this? Well, it concerns physical planning. We mean that the ideas on physical planning and above all, how those ideas have been put to life, what has been done in practice connected to this industrial transformation, was still from the point of view of big cities, very metrocentric concept, trying to recreate architectural ideas that might fit better elsewhere. At the same time, when social sustainability issues are concerned and housing shortage is addressed, it's not only about the end users of the built environment, of the housing provided, it is also about the process of constructing new housing or repurposing existing buildings. And construction branch is known to be the most incident prone. And while there's a vast body of research on risks and how do the incidents and the work-related health issues in the construction branch are pretty well studied, it's still problematic to change the branch and make it less risky. And if the transformation is big scale, there's a lot of construction work to do. And both concerning how the new housing or the old housing would look like. The community perspective is of special importance, addressing community preferences, for instance, with questions as suggested in a survey I've seen in, not survey, but questionnaire I've seen in the previous presentation. I have similar questions in the survey that we use in my dissertation, or through living labs when the same group of people might meet several times to show their perspective. And we hope that combining those three perspectives might provide a new and deeper understanding on how sustainable housing can be addressed, connected to the green transformation. And before I switch to my last slide and my name and address, which I hope you use in case of any questions, I want to show you the picture of the town of Kiruna, which is being affected by the industrial transformation. Below you can see the mine over here. You can see the old city center and the new city center, which was constructed using both the community perspective, the digital tools that has been used both to analyze the weather, the position, and to do the social sustainability 3D mapping of the area. Thank you so much.
Thank you, all presenters. So now we have time for discussion, so I will ask all presenters to come to the stage. I'm looking forward for questions from the audience. Any questions? Comments? Yes, please.
Thank you. My name is Elina Hassel. Thank you for the interesting presentations. I'm a tourism researcher at Salt Lofoten here in Norway, and I was wondering, I've been researching a lot of digital technologies in terms of tourism development, and you talk about the society in general, and what interests me there is the age and the digital literature skills of the local communities. And especially here, if we think about northern Norway, and we leave the island where we are at the moment and go further out, what kind of insights or ideas you have concerning doing digitalization outside of the big cities?
Certainly, I'd say the people of North Norway are very digitally literate on average, but there are groups where there are lacunas and levels of skill vary. And being aware of that is incredibly important. All too often, the digitally literate, or even just the people who are articulate, are actually able to get a huge influence. And being aware of that bias, in your research is pivotal. Good question.
I can also make just a short comment that I have a colleague in SINTEF which is looking into digital divide, and her findings are that the digital divide is more complex than we thought of earlier, where we thought a lot about age or what you could call demographics. It's more complex, and there's not necessarily the old truths are coming into play. So it's an area in movement. Yes.
Another question?
Thank you, everyone, for some really interesting talks. My name's Jan. I'm a family doctor using service design method at the moment. And my question is to Solba. Really interesting about this trilemma. My questions are quite practical. One is, how difficult was it to construct questions whereby answers all had validity, rather than kind of the usual binary, how many times do you do something, yes or no type surveys? And also, whereabouts can we what sort of programs have you used to do the surveys that you've done?
The tool that we use is called Voxt. It's a startup company in Trondheim, and we work with it. So I've been working with them. So that's a commercially available tool. Writing trilemmas is incredibly hard. Björn and I worked on it, and it's incredibly hard because we're so tuned into having multiple choices or binary questions, right? So that's very hard, and you have to learn how to do it. And one part of that particular technology is actually getting people to create those trilemmas, because the situations you're faced with, you know better than me, right? But I also noticed that what was coming in from the people, the co-created questions or trilemmas, were actually very tuned into yes or no questions as well. So yeah, it's not easy. It's kind of thinking, okay, it's an open-ended question that should make you reflect, is how I go by. But I must admit, we struggled, and it's not easy. But you learn through practice, and you engage with the people in the first place anyway, and that's mainly right.
Okay, thank you. I guess does it work? Okay. I guess it's a question to all of the presenters. So thank you for very inspiring. I'm not in this field at all, but I work as an advisor at the Research Council in Norway. So these presentations were, very different. Started from basic science, working with advanced development of models with high resolution, and towards implementing virtual reality or augmented reality to visualize how a city or a smart city can be done, and then towards co-production with engaging community and people. So what is really needed, because it's all this technology development and research-based development is quite advanced and, I guess, expensive. What is really needed to make use of these technologies to develop smart cities? Where is the limitation? Who is actually taking this initiative in order to use these opportunities better in developing municipalities or towns or whatever?
Yeah, I can speak for the virtual reality, augmented reality part of that. That's accessibility, because this technology isn't widely available to people in general. It basically it should mature so that it becomes a little bit more common for people to use. But other than that, when such initiatives are set in motion, governments and organizations need to have a toolkit basically for people to get access to this technology.
I would like to comment it from the point of view of 3D tool mapping social sustainability in subarctic Arctic environment. So what we found that the interest for those digital models were the greatest in the municipalities when the project was in the making. There was a lot of curiosity, interest, co-financing. There were a lot of co-finances in the project, so they were not driving their agenda, but there was a genuine interest. But when the model was ready, what was used the most is the distribution of energy use. So this model went from subarctic small scale to being used by the government. But when it comes to social issues, I'd say what was actually used by the municipalities and several actors were rather the results that you could phrase in words outside of the digital model, like that people are not less concerned with building environments close to big roads in small cities, which is typical of a big city. The closer to big roads, the less people are content with built environment, which happened to not be the case in the same way in the small Arctic cities that we were analyzing. That was of interest. They went deeper into how can more houses be constructed closer to the roads if it's logistically relevant. But the small details on even the big picture on segregation versus not, I would say it was not as used as it was demanded in the beginning, which is peculiar, something for us to further think about.
I would like to continue the answer starting from the word segregation and access to environmental services and goods, because it has been mentioned several times here that all these digital technologies allows us to see and therefore made smart decisions on invisible things. We have in Bergen such a very nice and concrete experience. Say you have a bad air quality due to particle pollution from wood burning, and you want that no one will be affected by extremely bad air quality that cause asthma, other health problems. No one wants this. But you have only limited economic incentive to deal with the problem. How to use this money available in the port in the best way? And that's what we can solve with this modeling and digital techniques. So we can explore digitally several scenarios, choosing the best scenarios which will allow the cheapest way to satisfy this basic need of people, democratic need of people, to access for good environment, healthy environment. And in our case, that was 50 million crowns in the pot of incentives. And if all this money would be used in the they didn't listen us, but if they would, they can implement even a better solution with and reach even better results. Given this money for certain areas in the town which are really affecting air quality for everyone.
Can I just add a short comment? As a lot of people are aware of these days, is that generative AI, such as ChatGPT, is definitely something that is dominating the public discourse when it comes to technologies. And as I heard your question, yes, the data models is of course complex, and for me, from my field, for example, I would not be able to read the data of Igor without which Igor and his colleagues presents without good visualization tools. But from sort of kind of technology optimistic point of view, I think ChatGPT, it's you know, it's text to text in a way. You prompt in what you want it to produce, and you're probably also aware of that. AI is also capable of doing text to images and also text to video. And I can mention now that also software companies such as Roblox, the gaming company, you're now able to. They're working on a technology that is text to a 3D environment, so that you can write in what you would like the 3D room to be like, and it produces this out of what you chat in. So from a democratic point of view, you can sort of see the outlining of how people with little or less to nothing can sort of create and visualize complex data in an easy way from a text prompt view in the future, most likely. And this is also very interesting in the XR perspective. also out of the context we've been talking about today. So there is probably in the future able to create also real-time generated visuals based on, for example, biosensors and etc. Yeah. Interesting.
Thank you, Per Estore, because that was my question. You answered without question. And the question was, what is next? What is the future?
Yeah.
So now you answered. But of course, like a scientist to the scientist, so there are many challenges behind what you said.
Yeah.
Please, Brian.
I think a very interesting thing to look at will be, I know with architectural firms, when they got CAD, they thought CAD would be wonderful, but then some architectural firms I knew insisted that their new architects learn how to draw with a pencil because they were able to communicate. And I think you're exactly right. There'll be fascinating things that will come out, but also we just have to be very aware that like CAD, you can end up with a kind of CAD-y look as opposed to a human creative look. But it's an extraordinary time, and I'm actually saying, I'm quite envious. We asked ChatGPT, how do you know if someone is cheating in an exam with ChatGPT? And actually came up with some really good answers.
Applause to all presenters. Thank you for coming, giving these questions, so they're now free to talk with you.
And we also have another session in the afternoon if you want to come by.